Hello, this is Scott, and in this video I'm going to use a graphical method to show why it takes more torque to rotate a cam with a higher slope. So in this sketch I have two different cams. They both start at a radius of 0 and progress to a radius of 6.28, but this cam does it faster. Goes from its minimum to maximum radius in half a rotation, whereas this cam takes a full rotation to do so. So this cam has twice the slope. And what I've done here is I've drawn two circles to represent your cam rollers. And the contact point between the circle and the cam profile is set at 3 units from the center of the cam in both cases. They're set equal to each other because torque, of course, is dependent on the radius. So in order to have an equal comparison, they must be at equal distance from the center. So next I have two lines that are tangent to both the circle and the cam profile. And the reason I have those is so I can define this line and this line, which are perpendicular to the tangent lines. And this perpendicular line, well, these perpendicular lines represent the force between the cam and the roller. And the reason we know this force is perpendicular at the point of tangency is because the roller won't react. Any component of force that is tangent to it, it will simply roll. So next I've defined lines between this center of the cam, or radial lines from the center of the cam profile to the contact point. And these lines are going to be the direction of the motion of the cam at that point. No, sorry. Those lines are the motion of the cam roller as the cam pushes it outwards away from it. And so there's going to be a certain amount of force that is required to push the cam roller in this direction. And so to make it easy for ourselves, we're going to arbitrarily say that the amount of force required to lift the cam roller is going to be 1 unit of force for both, and that's equal for both of these so that we have an equal comparison. So now that we have the direction of the force between the cam and the roller, as well as the magnitude of the axial or the radial component of force, we can we can calculate the component of force which is perpendicular to the radius, which SolidWorks has done for us. The torque required to turn this is going to be this unit, this component of force multiplied by the radius, which is 3. So this is going to be about 1. So this is going to work out to 1/3 of this, or 1 unit of torque. And this is twice as much of it, which will be 2 units of, which will work out to 2 units of torque required to turn the cam, which is exactly twice as much, which demonstrates that the torque required to turn the spiral cam with the constant slope is proportional to the magnitude of its slope. And so anyways, using this method, if you know the actual amount of force required to lift the cam roller, then you can use this same graphical method to calculate the amount of force required to turn the cam, which is how I did the calculations for the team when we were designing the 2014 FRC bot, which worked out quite well, I do say so myself. But anyways, I think that's it for this video, so thank you for watching, and I hope it was helpful.